There are two types of problems that we're going to have to solve with regards to a kite. The first one is going to be with the angles of a kite. What I want you to recognize is that your long diagonal in a kite, in this case segment AS, is a line of reflection. Therefore, I could fold this kite over and D would map directly to I, and essentially it's a reflection. That is what gives us a lot of our properties of a kite. Since segment AS is the line of reflection, if I folded D right onto I, we can see these are going to be congruent angles. Okay. These two angles are going to be congruent angles. But they're not all four congruent to each other necessarily. The only angles that are bisected are along that long diagonal, because if I folded this over, segment AD would map onto segment AI. I now know these angles are congruent, and then vice versa. I know these angles are congruent. Again, they're not all congruent to each other. The other major thing to remember here is that the diagonals, long and short, are perpendicular. All four of these are 90-degree angles. Beyond that, we have to remember exactly how to do triangle sum theorem and name angles. Okay. So when I give you that the measure of angle DSI is 54 degrees, I start at D, I go to S, and then to I. That's this entire angle. If the entire angle is 54, and when I fold over on the long diagonal, I'm cutting it in half, half of 54 is 27. These are both 27 degrees. We already talked about how all of these are 90 degrees, perpendicular. I also have given you the measure of angle AIY as 47. Start at A, go to I, then to Y. This is a 47-degree angle. The rest is triangle sum theorem. If that's 90 and that's 27, triangle sum theorem tells me that this is 63 degrees. 63 degrees. If that's 47, this is 47. Again, it's a reflection. Okay, triangle sum theorem here, if that's 90 and that's 47, this one is 43 and 43. I have every angle labeled in here before I even looked to see what I needed to find. The rest should be easy. It's copy it down, possibly do an angle addition problem. So first, measure of angle ADY. Start at A, go to D, then to Y. That's this angle here. That's a 47-degree angle. Angle DSY. Start at D, down to S, and then to Y. That's this angle down here. That's a 27-degree angle. IAY, I to A to Y, is a 43-degree angle. DAI, D to A to I. Now that's this entire angle. That's not 43. That's an angle addition. 43 and 43 is an 86-degree angle. Angle SDA, S to D to A. Again, it is an angle addition problem, but it's not 47 times 2 or 63 times 2. These along your short diagonal are rarely, if ever, congruent. I have to add 63 and 47. I get 110 degrees. And angle SYI, that's my angle at the intersection of the diagonals, that's a 90-degree angle. The second type of kite problem is the one about the side lengths of the diagonals and of the sides. The key in this type of problem is the Pythagorean theorem, because we do have to recall, first and foremost, the diagonals are perpendicular. So you're going to have four different right triangles down here. All of these are perpendicular. These are all right triangles. So given the information, I know the short diagonal, because again, KT, segment KT is my long diagonal. That's my line of reflection. If I folded this kite over, this segment and this segment would map directly on top of each other. They're congruent. So I now know this is 12. Let's look to see what I'm asking you to find here. I'm asking you to find segment KI. Well, how does that help? If I need that segment, I now have a right triangle here. I now need to use the Pythagorean theorem to solve that right triangle. These sides are the legs of the right triangle, 5 and 12. Opposite is the hypotenuse, so legs squared, 5 squared, plus my other leg squared, is equal to my hypotenuse squared. So 25 plus 144 is 169, square root of that, we get 13. So we just used the Pythagorean theorem to find that this is 13. Okay, well if this is 13, this is also 13 in a kite. Those consecutive sides are congruent. What else have I asked you to find? I've asked you to find segment NK, which is weird because there is no N. I think I was meaning to ask you to find segment TK, which would be the length of this entire diagonal. Well, we know one part of it is 5. What's the other part? That's going to be Pythagorean theorem again. I need to use this triangle and Pythagorean theorem. I know that one leg is 12, 12 squared, plus my other leg, which is segment ST squared, is equal to my hypotenuse, 37 squared. When we solve this, we get that ST is equal to 35. Now that I know this is a side length of 35, I know that TK is 5 plus 35, or 40. Lastly, I need the perimeter. Well, I know KI is 13, KE is 13, I know IT is 37, so what's ET? Well, if these two sides of my kite are congruent, so are these two sides of my kite, so this is also 37. Perimeter is adding all the sides, so I have 13 plus 13 plus 37 plus 37 for a perimeter of 100.